proposals for improvements for the token standards. This has been something that's been going on for a while now. We've kind of been discussing it with some people in the community, people on the flow team for probably, at least a year now, since initial discussions got started. But we really started working on it a little bit more in earnest with the community about 6 months ago. So some of you will already be familiar with what I'm describing here, but just wanted to get more people familiar with what's in the proposals, and what some of the unanswered questions are for these upgrades, and have a recording so we can share it with more people who aren't able to come to this discussion. So so we'll start with describing the problems with the current token standards. We'll talk about some of our improvements, and then I'll give a brief explanation of like what most developers can expect if this is approved, how they can expect to have to update their smart contracts, and then we'll have some time for questions, and hopefully we can get through enough to have enough time at the end to discuss one of the big unanswered questions about how we're going to manage events with the new standard. I think we can just get started. So I have some important links I'll post in the chat here. So we originally posted our proposal for the new standards in this forum link. That has had a lot of discussion. The original proposal, the proposal has kind of changed from what is in that forum post. The core of it's still the same, but there are some parts of it that have changed as we've had more discussion. And then we have these two GitHub pull requests are the proposed code changes to the actual fungible token and non-fungible token standards. So you can actually open those and look to see what the actual code looks like with the changes. Pretty soon, once we kind of figure out this last big question about events, I'm going to make an actual flip for the token standard proposal, and we can finish like all of our discussions there for like the last phases. So I just want to like make sure it's clear to everyone that the changes that we're proposing here will have quite like large implications for developers in the Flow community. Most of the changes that we're proposing will break all fungible token and non-fungible token implementations, as well as depending on some of the changes could potentially be breaking for some third-party contracts and transactions and apps that integrate with them. We want to try to minimize the amount of breaking changes for kind of like second-order breaking changes for apps or for third-party smart contracts, which we'll kind of get into a little bit later. But at the bare minimum, it'll be hard to implement the changes that we want here without breaking the actual like fungible token and non-fungible token contracts. So because of that, like this is a really important discussion, really important that we get as many developers in the Flow community involved as possible, get as many eyes on this as possible so we can choose all the right features and get an idea of what people are comfortable with, if we actually want to move forward with most of these, or if we want to cut some to make the upgrade process easier, make the breaking changes a little bit easier to deal with, but also just to understand like why we're doing these. So as hopefully many of you know, we have a milestone coming up in the Flow community called Stable Cadence. It's basically when we say that there will no longer be any more breaking changes for the Cadence language. And these token standard improvements are going to be part of Stable Cadence. And while these token standards aren't like a part of like the core language itself, fungible tokens and non-fungible tokens are such like an integral part of the blockchain like development experience that that they might as well be part of the language because so many smart contracts use them. So that's how we're treating it. Even though like smart contracts can continue to be updated after Stable Cadence, this is something that we almost view as something that can't be updated with a breaking change unless absolutely necessary. So we'll just get into some of the problems with existing with the existing token standards. I'm not going to share every single problem that there currently is, but kind of the big ones. There's not enough time to get into all of it, so I highly encourage if you want to learn more about it to go check out the forum posts and the fungible token and the pull requests to kind of get the whole picture. So currently, our token standards are handled with contract interfaces. So if you want to define a token smart contract, you have to implement the fungible token interface or the non-fungible token interface. And those interfaces have pretty strict requirements for like methods in your contract and type definitions. And it can be a little bit restrictive for developers who want to like have more flexibility with how they define their tokens and what is actually required to define a token. And related to that, that means that you can only have one token defined per contract. So this is an example of like our example token contract in the fungible token repo. We have this vault resource defined, which is specified by the fungible token contract interface, and then we have like these specified like storage paths, specified total supply that only describes this single vault type that's defined in the contract. But you can imagine that many developers will want to define multiple tokens in a single contract or multiple NFTs in a contract, but currently that's not possible. And we want to just give developers more flexibility to be able to say that a token is defined by the interfaces that it implements and not by like a single contract. Additionally, as part of Stable Cadence, the Cadence team, the Cadence community wants to remove nested type requirements from the language. Basically, what nested type requirements are in like an interface requiring that an implementing type defines certain types within it. So, for example, an event that an interface specifies is a nested type requirement because events are types. And then the bigger one is these vault or collection or NFT type requirements that we have in the token standards. It's a language feature that not a lot of other languages have. And also it's not, besides the token standards, it's not really used very much outside of the token standards. And we've gotten some of like it there. We haven't really like achieved some of the benefits that we thought we were going to get from it. But there are some costs like that make things a little bit hard, the language like hard to reason about. For example, like sometimes you'll have to make comparisons between like your token, your vault token, and like the kind of generic fungible token vault, because they're both these kind of like concrete types. Whereas it would be easier if you could make those comparisons with like an interface, like a vault like interface type, instead of this awkward like pseudo concrete type defined by the fungible token. So there's more details in the proposal about this, but basically we want to remove this feature from the language, which would require changing the standards to comply with this. Additionally, the current standards do not directly integrate with the metadata standard that we have for tokens. The metadata standard was proposed and accepted after we had already designed the original token standards. And recently we've upgraded the standards a little bit to kind of support the metadata standards, but we'd like to make a more direct integration with the token standards so that it's a little bit more clear in the code, and has some more stricter like requirements for metadata than it currently does. Additionally, we don't have any like path requirements for tokens. This is still kind of an open discussion that we have with the V2 standard for how we want to like enforce paths, or if we want to enforce paths, but it's something that we definitely want to think about. We also have some fields that we like specify in the standards, like total supply, which don't necessarily make sense with these updated standards, especially for NFTs. A total supply field can feel kind of meaningless sometimes, and so we want to remove that field to allow projects to have more flexibility with how they want to define that. Additionally, in some of the token types, we have like a balance field in the vaults. We have ID for NFTs, and we have the own NFT fields and NFT collection that can be a little bit restrictive for how developers want to store like a balance or their NFTs. So we wanted to remove those requirements and just put in methods defined on those types that return a balance or return an ID or return like a list of like the NFTs that you own. So developers can, for example, if they want the balance of a vault to be like a composite value that like looks at multiple different balances and combines it, or if we want the owned NFTs in a collection to be stored in multiple different fields or something like that, to not have to require that the developer do that. And then with the ID, some developers might want to also choose a different way to identify an NFT instead of just the 64-bit integer that we've been using so far. And many developers just want to use the resource UUID for their NFT. So now I'm going to talk about some of the improvements that we've proposed to deal with some of the problems. So as it says in the slide, a lot of these are still in flux. Nothing that I'm describing here is like set in stone. It's all stuff that's still being discussed. So any of it could change. So this first improvement I'm describing here deals with the problem of the only one token per contract and the requiring the like interface implementation for defining tokens. So we want to make it so that fungible tokens and non-fungible tokens are defined instead of by the contract that they're in, defined by the resource interfaces they implement. So we basically want most of the functionality required for a token defined within the actual token type or collection type for that token instead of in the whole contract. So as I show here, for a NFT collection, instead of having the storage paths for that collection stored as a field in the main contract for that collection, we actually put the storage paths in the collection itself. And we put the function to create an empty collection in the collection itself, and say that an NFT or a collection or a vault, if it implements the correct interfaces, such as the provider and receiver interfaces, that makes that token an actual fungible token, not necessarily the fact that it's in a contract. So you can imagine, like, you could potentially define a token in a non-traditional token contract, instead of having to have like separate contracts for tokens. So that just gives developers a little bit more flexibility with where they can define their tokens and what they can do with their tokens, since it's all kind of encapsulated in the resource where the token is. Additionally, we have some smaller improvements we want to do. So currently, we have introduced a transfer function to the standard. This one's a little bit contentious, but we have had a lot of users who there's a lot of times when they want to have the simplicity of calling a single function to do a transfer, and instead of having to withdraw and deposit. So we're currently exploring if a transfer function and a transfer interface would be useful. Then currently, the borrow NFT function, which borrows a reference to an NFT in a collection, it does not return an optional. It panics if it cannot find the NFT that you specified, which isn't a very good pattern, because sometimes you don't know if an NFT has a specific ID. So want that to fail a little bit more gracefully. And then we also want to more deeply integrate fungible token and NFT metadata. So we're exploring putting having like utility functions defined like on a contract to return, like, say if you have multiple NFT types defined in your NFT contract, instead of having to look directly on the NFT, a contract may want to have utility functions in their contract to return metadata about the NFTs it defines from the contract, without necessarily needing to go directly to the NFT. Then I described earlier how we don't necessarily want to require that NFT ID fields or vault balances are a specific value or a type. So we want to remove those fields from the interface definitions to allow users to have more flexibility with how they manage those fields. So this is just kind of a brief overview of some of the improvements. A lot of them there's some more that are described in the forum posts and in the various pull requests. So I definitely recommend going to those to learn about those and participate in the discussion. So now I want to talk about what users can expect from the migrations if the current proposals are accepted. So currently, like what we're trying to do is we want to make the migration as easy as possible. So we want users to be able to basically just kind of like follow like kind of a list of instructions, and be able to like just make quick changes to their contract, and get it upgraded on like the same day that they start making the changes. So a lot of the changes are breaking. Not all of them are, but the upgrade should be fairly easy. And like I said earlier, ideally we'd like to avoid the breaking changes affecting like second order, third order apps or third party integrations, because that can start to get a lot more complicated and a lot more, yeah, just difficult to deal with if there's lots of different things breaking down the chain of integrations. So some of the changes for the token contracts that you should be aware of are there will be a few new interface conformances that you'll need to add to your contract. There may need to be some new event signatures and event emissions, depending on some of the changes that we make to events. There are some new methods that we're introducing that you'll need to add. There are some new methods that will have default implementations in some of the interfaces also that you won't have to add, but that could be useful depending on what you want to have in your contract. And then some of your scripts and transactions would also need to be updated to use some of the new methods and the new types and interfaces that we're changing to. But most existing token contracts, that's basically it. A lot of these, like, there's some new features that like you wouldn't need to worry about updating to, because just if you already have a token contract, for example, you might already have only a single token defined in your contract, so you probably won't be adding a new token to your contract to make use of those new features unless you specifically want to. So yeah, they all are like pretty quick changes. For app integrations, this is something that's like I said, we're still kind of trying to minimize and trying to explore. We're having an event discussion about how we want to manage events in a little bit. So depending on the outcome of that discussion, there could potentially be updates required for event listeners for app integrations. But like I said, we really want to make it so that events are backwards compatible, so that like apps who depend on monitoring events from certain smart contracts don't have any breaks in service because they weren't able to upgrade in time. And then there's some apps use scripts to directly query information. So there may need to be there'll probably need to be some updates to some scripts that dApps use to support some of the new getter methods for metadata and stuff like that. But some of the new methods that we're adding for getting metadata and things like that will likely not be used until like new developers start deploying new contracts to support, like, for example, like having multiple tokens per contract. So this should hopefully give apps a little bit extra time to kind of like get around or work around some of the new features and everything. So we expect that apps won't have to worry too much about their upgrades, but we'll still be exploring some of those changes. So, well, before I get to this slide, I want to just kind of like show an example of the code for this is for the like an actual token implementation, just to show like some of the changes. So this is our example NFT contract. The one on the left is our current token contract, and the one on the right is the example NFT contract that implements the new token standard. Currently, we have it as an interface, but we could we would like to make it a just a regular contract that just defines interfaces. Like I was saying before, that we want to have things defined as in resource interfaces instead of contract interfaces. So this isn't really necessary right now, but it's just the way we currently have it. So basically, there isn't much initially to add. You still have your metadata views in your contract. Hopefully, those can all stay the same in the NFT definition. But then when we get to our collection resource, a few things change. We would you'd want to add maybe some getter functions for your storage paths for your NFT collection, and then we want to add a get accepted types requirement to the collection interface that can just specify which types a collection accepts, because we want developers to be able to define collections that can store multiple types in them, instead of just a single type. There are there might be some changes to some other function signatures, like the borrow NFT function. Like I said, that currently returns a non-optional, but we want to change it to return an optional. So that'd be a small change. And then we'd also have to add the create empty collection function to the collection resource. And then these functions down here are things that we would want to make optional. So you only need to add them to your contract if you want to support returning existing or additional metadata. So on your contract, you could add a function to get the NFT types that your contract supports, the collection types, and then various like metadata about your collection. But most of these functions would be optional. So and that's pretty much it. Everything else down here is just like the optional like minter resources and stuff. So the changes are relatively minimal so far, and most of the changes don't actually require much code changes in an actual contract, so it should be relatively easy. So yeah, like I said at the beginning, we're looking for feedback. Definitely go to the forum post and leave a comment there, and go to the PRs, leave comments, check out the code, see if it makes sense to you. Even if you like agree with it and you're totally happy with everything, even just like a comment with like a thumbs up or something would be useful to us, just to know that people are looking at it, and that we're getting more eyes on it. But especially if you've got the time to dig into it a little bit more and think about what would be useful for you and for other developers in the Flow ecosystem, we really like to hear that. And additionally, we want to hear more about the feasibility of the actual migration. So if we're not considering something like a difficulty for upgrading smart contracts or dApps, we want to hear about potential issues that there might be that could yeah, that could hurt apps that are using Flow right now if we introduce these breaking changes. So yeah, we just want to hear from more people. We've already had a lot of really good discussion, and we just want to land on something that's as powerful and easy to use as possible, because after stable cadence, like I said, there's not going to be any more kind of core upgrades to the token standards, and so this will be something that will live forever on Flow. And if we ever want to introduce a new token standard after this, it will have to be a whole new smart contract, and so then we get to we would have difficulties with, oh, now we have two token standards and you have to deal with multiple token standards, or do more complicated ways of upgrading your standards. So we really want to set ourselves up for success long term with these ones. So having as much discussion and feedback as possible would be great. So I think that's it for the main part of the presentation. So I want to open it up for questions and discussions about the core proposals. And then once we're done with that, I want to try to talk about some of the proposals that we have for events in the new standards. But I'll go. We'll get to this in a second. So does anybody have any questions about the upgrades before we start talking about events?
Feel free to type your questions and we can read them out as well. You don't have to unmute and speak. And also, I mean, Josh, it was a ton of information, really well presented, but it was a lot. So
yeah,
do feel free, people, you can watch this back later on a YouTube account. You can ask questions in Discord. There will be opportunities, but go on, Austin.
Yeah, so nice to see all of this being talked about. I know we've had it in forums for quite a while. I guess my main question right now, when we think about allowing multiple types in a contract, how will we be able to ask for the NFT definitions in a contract as an example? How would I be able to ask this example NFT actually has NFT 1 and NFT 2 in it? Is there going to be a way? Because that's different from what collection types are supported to be deposited. This is what definitions exist in this contract. Is there a plan for that kind of capability?
So that's what these methods that I defined here you would return. So you can query a contract to return the list of all of the actual NFT types that it implements. And then you can, and this also, like right now we call these NFTs, but it could be called just like Josh NFT. And so there could be a list, if there are multiple, list of all the different NFTs that it defines. And then we also have a utility method here that can say, okay, which collections support these NFT types, so you can get a good idea of how everything is organized in the contract.
So is the assumption then that this get NFT types is only for the definitions in this contract, or is it to be used for, here's what you can deposit into here, into collections that come from here? Because that's actually how I read it, was this is a Dapper Sports collection. You can put Top Shot or All Day or Strike or La Liga or whatever else comes in the future. Like that would be how I read this versus, and I could just be totally off, versus, here's the types that I've defined in here. And that ambiguity might matter, which is, I don't know, the only reason I'm asking.
It was both, actually, Austin. So
Yeah.
previously, Josh showed a different function that was on the collection that said, what types does the collection support? And this is the contract saying, these are the types I define.
Got it.
Yeah,
Okay.
yeah. So here, yes, like get accepted types. Like this function is in the collection, so you can call that to see which types of collection supports. But you do make good points about like wanting to be able to say that like maybe a collection can store types that aren't defined in the contract where the collection is defined, and so we want to have some way some way for the collection to clearly indicate that like it can store more types. So that's something that I want to explore a little bit.
Sounds good.
Any other questions? All right. Well, I guess if there's no more questions, if you have, I mean, if you do have a question, feel free to still post it in the chat. But if there's no more questions right now, we'll move on to talking about events. So as I was saying earlier, as part of Stable Cadence, the Cadence community would like to remove nested type requirements from the language. And currently, there's not really much of an issue with removing like the vault or collection nested type requirements from the token standards, because we have suitable replacements with resource interfaces instead of the resource types. But events currently use nested type requirements because an event is a type, and in the fungible token interface, we say that any contract that implements a fungible token needs to also include these standard events like deposit and withdraw. And that's useful because it's useful to say that if you are a token, if you're implementing a token, you need to have these standard events, because as we know, there's a lot of different apps rely on events having a standard signature to monitor token ownership. And so it's useful, and so we want to be able to still have some of those useful guarantees for events, and we still have a few different ways that we think could still support this, that we want to kind of nail down. So ideally, like I said before, we want to avoid breaking apps who listen for events when we do our upgrade. So for example, we'd like events to have the same signature. So like we want them to still have like the address of the contract that they're emitted from. We still want them to have the name of the contract. We'd like apps to still be able to look for the arguments for that event in the same order, instead of like switching around the order. So yeah, we want to make it as easy of an upgrade as possible. And we'd like for all token contracts to emit the same kinds of events for like deposits and withdraws. Token contracts can still would still be able to define custom events for for various things that they define for their contracts, but like those kind of core like deposit and withdraw events, we still want those to all look the same for any token contract. So we have a few potential solutions that have been proposed. So one of them is to remove nested type requirements for everything except for events, which would basically make events behave exactly the same way that they do now. But we wouldn't be able to completely remove nested type requirements from the language. So it is a little bit awkward, but still a potential solution that would be kind of like the least breaking for smart contracts. We could say that we don't want to enforce event requirements in contracts at all, and just say that contracts can just define their own events. Obviously, this probably isn't ideal because, like we said, we want to have at least some guarantee that contracts are emitting the correct events. I mean, most contracts will just copy and paste their events from other examples, so this would work. This would work most of the time, but not really great to not have any sort of requirements. So now we're going to get into some of a little more, some of the bigger changes that could be interesting. So we could allow composite types like resources to inherit events from the interfaces that they implement. So for example, we have a GitHub issue here that was proposed to say that an interface can define an event to for deposit, and then the resources that implement that interface can emit that deposit event in their contract to say, so it's not like a contract level event that's being emitted, it's just this interface defined event. There's an issue in the Cadence repo here if you want to check out that proposal. And then an additional proposal is saying to actually allow the interfaces themselves to emit events. So this means that the receiver interface for Fungible Token can actually emit the deposit event itself whenever a contract or whenever a resource that implements that interface, whenever its deposit method is called. So this would happen in a post condition for that deposit method in the receiver interface. So this would basically say that contract developers would not even have to worry at all about writing the code to specifically emit an event in their contract, because it would just happen automatically, because we have the amount argument from the deposit function. We can get the address of the contract, the address of the resource that emitted it, and we could even construct that event emission to still have this fully the same signature as it currently does with the correct contract address and contract name and everything. So these are kind of the four proposals that we have. We've got about 14 minutes left in this to discuss it. And I don't know if Deet or if anybody else on the Cadence team has anything else they want to add to this. But yeah, we've kind of planned for the last part of this meeting just to kind of see what people think about these proposals and see if there are any additional proposals that people might have for events. So if anyone has anything they want to add to this, feel free to unmute or raise your hand. Austin?
All right, yeah, I talk a lot. I guess two things. One, I would we by this change be able to say filter on the NFT contract deposit and then get any deposit from a range of blocks, or would we still have to know each individual type? Because that's one of the really kind of annoying parts about trying to look for all NFT transfers, for instance. And maybe this is a way to make that a lot better. Because then if the base contract emits it, maybe there's a way to start more maybe accurately filtering for that kind of thing. And then secondly was just, if interfaces can emit events, then it'd be really nice to add new events in the future too. Like when an NFT is destroyed, I don't think we have an event for that. So would be very much in favor of that kind of flexibility. Or I don't know, consumers of that interface wouldn't have to update themselves for the standard to evolve or get better.
Yeah. So
go
if I
ahead.
can jump in real quick here, Josh.
Yeah.
What you're talking about, Austin, is You could argue it's, I mean, I would argue it's kind of an orthogonal question, but obviously it's deeply related, right? Like one question is how do we emit events, and the other question is how do we query events? But if we make events harder to differentiate using the existing query methods, we've regressed using the blockchain in general. So a separate group is looking at how we can make sure the Access API gives finer grained ability to query events. And so if we went with the post condition, like the last option here, where the post condition on the interface itself emits events, one of the arguments to that event would be the concrete type of the vault in the case of deposits, and potentially both the collection and the NFT in the case of NFT deposits. And then, of course, then the Access API would require you to be able to filter on those things. And so we're aware of the fact that having one event type is convenient for some use cases, i.e. the I want to watch everything on the chain use case, and deeply annoying to people who only want to watch certain events because we don't have a good filtering API. So that would sort of be, we're aware of the pressure that puts on the Access API to make this change, I guess is the short answer.
Yeah. And just to add, you mentioned like wanting to add new events. Yeah, we definitely have the opportunity with this upgrade to add any new events that may be useful. So if anybody has any other events that they would potentially want to add to the standard, we definitely want to hear those proposals so we can get those included if the community agrees that they're useful enough.
Hey, Bjartek here. So new events is cool, but what about making the old events human readable as well? So right now, all NFTs will support the views, right? The metadata views. That means that you can optionally have a display for any deposit or any withdrawal or any transfer. Oh, I will strongly argue that having human readable events in addition to machine readable adds lots of value, because you don't have to look at another source to just know what this is. So what was the name and even the image, the URL to that image of this thing that was airdropped to me? It adds a lot of value. I'm not saying remove things, I'm saying adding things. So adding fields normally doesn't break indexers, it's only changing them, right?
Yeah, I know that that's how it is for Go at least. I'm not 100% sure how FCL event indexers work, but yeah, for Go, you adding additional parameters doesn't affect the event indexers. They just have access to those. So you're saying you would want to just want to add an additional parameter to each like deposit event that just shows like the display view for an NFT?
I mean, what we do at Find is we have one contract that resolves an NFT struct based on a view resolver. So it just tries to generate whatever we can. It's quite verbose. It generates quite a lot, but for us it adds a lot of value because it basically means when we want to index an NFT, we don't have to go to an external data source to fetch anything. We can just read that data and index that as a single thing because it's independent, it's human readable, and it's machine readable.
Yeah, I think that's a really good idea. I think I guess there may be some questions about how much data the event can have, but I guess the display view is usually pretty small. So I definitely think that would be useful, and I want to probably try to include that in the proposal.
Yeah, there might be a different solution here where like we make sure the resource ID is in the event, and then you can use the resource ID to query the metadata. And obviously on the maybe even Access node, but certainly scripts could hide that. Like, you don't have to, like, as a client, you don't have to make two queries, like what was the event and what was it. Like, somebody could, a convenience method in the middle could expand that. But as far as the chain is concerned, I think Josh's instinct there to be nervous about the amount of data is correct, because that could be a vector for attack where somebody creates like a maliciously large display metadata, and then we blindly copy that data into the event, and then suddenly that event either is a denial of service vector for the network, or is something that is a very expensive gas cost just to transfer this thing because you're emitting this giant large event. And so I think there might be a balance there where, as a client to the chain, you get all that data for free, which but the chain itself is just using a compact representation such as the resource ID.
But what if the data then changes? Because if the human readable data changes, then that event was done in posterity, not now. So you can ask for the data now, but you want to add what was the data then when it happened. I'm just arguing that things should be independent. So that the data should be there. It should be one thing that you don't have to do any other thing. It's a lot simpler because it's one thing. I get the attack vector angle, but there are other ways to handle that as well.
Yeah, I mean, my short answer would be to do a historical query, and I know that there's like time limits on that now, but archive is not far away, and so that is something that we should be able to handle in future.
Yeah, we can explore this discussion more in the forum posts and stuff. But I think it's a good thing that we should definitely, think about it a little bit more. Had someone else raise their hand? I thought I saw Dennis raise his hand, but I guess not. Yeah, so I think does anyone else have any thoughts on the event emission potential solutions that we have discussed here? Austin?
Just one more question, and maybe either you or Dee could actually answer if this is feasible. But one challenge right now with an event is, where did it go? And I know we have storage iteration, but storage iteration is broken for some accounts because if the contracts don't update, you can't use iteration to evaluate a type, and so that gets pretty hard for discovery. So is there any chance that deposits can tell us where something went? Or is that kind of just one, like including paths is another blow up of like too much data, or a resource doesn't know that information, and so it's just not possible. But it would help quite a bit to know, like, deposit went to storage/moment collection, or to all day moment collection, or any new NFT. You don't even need to know where it went, which is kind of in line with the initialization problem discussion of, like, users should be able to put things anywhere they want. And then it'd be nice in concert with that events can tell you that information as well.
Yeah, that's interesting. Yeah, I think, like you said, I don't think that resources have access to the path information where they're stored.
Yeah. Well, and they might not have a path, right? Like,
true.
It might be within an object that is itself stored within a path, or it might just be on the stack. So it's that notion of the back pointer or the up pointer in the tree, depending on how you want to think about it. But figuring out how to get to the root is something that it niggles at me. I know it's we don't have a solution for that, and I know it's really valuable. But I still haven't thought of it like a clean. I personally haven't found a clean, sort of general, it could solve any problem that we know how to implement. So I would encourage anyone who has ideas about that to go onto the forum or propose something concrete as a flip. Because I think that's definitely a problem we're not solving that would be very valuable to solve, and it's just not I haven't heard any suggestions, and I haven't thought of anything myself in terms of like what a clean solution to that problem might be. The best idea I have is resource IDs. Is both making sure we're reporting resource IDs and then having a mechanism to query resources by ID from scripts, right? So obviously you can't load an arbitrary resource by ID in a transaction, because that would break all of the security features of Cadence. But in a script, you should be able to query a resource by ID regardless of where it lives, and that might help a little bit, but it still doesn't get you all the way back up to the, well, what storage path am I living in?
Yeah.
So it's an interesting question, and one I think I would like to find a solution for.
Well, if you can query by type in ID in a script, right? So this is an example in FT with ID1. If you can query with that and get back something like a capability, a scope provider or whatever, then you can get the path from that, right? Or you should be able to.
Yeah, I mean, again, imagine the scenario of an NFT in a collection inside another NFT inside a collection is stored at a path, right? So, what is, how do you, when you ask that innermost NFT where it lives, what does it tell you? And so, I mean, again, like that's an extreme case, and that mostly doesn't happen. But when you're building language constructs, you got to try and at least gracefully degrade in the case of those edge cases. So figuring that out is an interesting one.
Like, for what it's worth, Floaty needs this, right? Like we do what you're describing, Dieter, where like when someone takes a loan out on our platform, we store the resource in another resource, and so it doesn't technically really exist to most indexers. It just is in limbo until its end state happens. So it is very much like I wouldn't say like super common, but it is a thing that for sure happens, definitely.
Yeah, and intentionally, right? Like that was a design decision of Cadence, is to enable that, and I'm very gratified to see projects like Floaty that use it.
Yeah. So we're basically out of time. So I just want to briefly mention one thing I forgot to mention earlier, that there were a couple parts of the proposal that were removed. Most notably, universal collections, like NFT collections. We originally wanted to define like a collection type that can store any NFT that users can use, but there was some pushback, and so we've decided to hold off on proposing that because it's not an actual core part of these token standard upgrades. Additionally, a couple people mentioned that they wanted scoped providers, which is basically a type that users can add to their account that says that instead of like a regular providers like that, which have access to an entire collection to withdraw or an entire vault to withdraw, it only says you can withdraw specific IDs or specific amounts from a vault. So we want to, for both of those, we're going to have separate flips, separate proposals for those that we talk about in the future. But yeah, like I said, they aren't a core part of these, so we want to keep this as focused as possible. Also, I'm going to, for these event proposals, I'm going to post a summary of these in the forum post, the token standards proposal forum post. So we can have like a little, like a mini vote or more of a discussion on it. And so if we definitely would appreciate if everyone could go to the forum post, and I'm just gonna like make it a little poll, just to indicate like which one that you kind of have a initial support for, which one you're most interested in, so we can kind of start moving forward. Yeah, thank you, Luke. So we can kind of start moving forward with some of these proposals, with some of the technical implementations. So keep an eye out for that. Yeah, within the next hour, I'll have it on there, and we can start doing a little informal vote. But yeah, like I said, for everything else, please comment on the pull requests and the forum posts for any other questions or comments you have on the proposals. Like I said, even if it's just an approval, just a thumbs up that you're happy with it, that's better than nothing, just to know that people are looking at it. So thanks to everyone for showing up, and we'll hopefully see you on the forums.